Hello guys, how are you? Welcome to my channel. So in my previous video, I discussed about a roadmap to become a data engineer. So as I said, I'm going to cover the roadmaps for becoming a data engineer, that is full stack data science engineer. So today I'm just going to give a roadmap about data scientist, what might be the roles and responsibilities of a data scientist in a company. So, and what are the main roles? So is data scientist only responsible for data modeling part, or he'll be responsible for deployment part as well? So what are the essentials required for one to become a data scientist? So basically, as we all know, in order to start with any of the software industry, we need to be good at one of the programming languages. In the same way, we have to be good at programming language called either Python or R. So there are major differences between programming languages named Python and R. So R is basically a statistical tool. So basically, it's mainly recommended for if it's mainly used by a statistician. So in earlier 1970s, so there were a lot of statisticians before machine learning and deep learning came into the existence. So that's where our tool and a statistical tool called SAS has become famous at that time. And nowadays, as we know, Python is the most popular language in terms of various libraries providing, and it's much more flexible to offer by a developer. So that's the reason why most of the companies are moving towards Python to implement many of the data science libraries called pandas, numpy, matplotlib, cbon, and if you're going for deep learning, we'll learn more about the ANN, RNN, CNN. So there are various other algorithms which includes one has to learn. Even in machine learning, we have scikit-learn to train a model, to divide the data into training and testing set. So these all the packages have been inbuilt in Python. So we need not to keep much efforts to write an entire code to train an algorithm. Rather, we can use the existing pandas developed by many of the authors. So that's one of the advantage. And apart from programming, so what is the next step do I need to learn? The next thing is mathematics. How much mathematics is required is the next question. So for that, it depends. So if we are depends on the each algorithm that we are going to learn. So for example, if I take linear regression, so we need linear algebra for that. And if you are going for naive base, so it works based on probability, that is conditional probability. So in simple, for a given x, there will be a value given x. We have to calculate what might be the chances of occurring event y, given that event a has already occurred. So these kind of things we'll learn more in naive Bayes theorem and statistics, as we know. So every basic things, every data scientist has to learn statistics first, because to understand various measures of central tendency, various methods of dispersion in a given data set, so we have to understand various techniques in statistics. And coming to the databases, so we also need to be good at either one SQL database, and one non-SQL databases includes either MySQL or Oracle, or it can be RDBMS, any of the database. Uh, And we also need to be good at non-SQL databases, includes Couchbase, MongoDB, Cassandra, HBase. There are various things. And in machine learning, so coming to the main part, that is machine learning, what all has to be learned in machine learning? So in machine learning, we will be having predefined algorithms called in supervised. Again, in machine learning, again, we'll be having supervised learning, unsupervised, and reinforcement. So in supervised learning, we'll be having a given input, and we know that we are going to predict a variable y. So if we have an input and if we know the output that we are going to predict, so that particular things we'll call it as a supervised learning algorithms, which will explain algorithms called linear regression, logistic regression, decision tree, random forest, naive Bayes. These are the various algorithms which will be used for, and there are others as well, which include support vector machine, decision tree regressor, decision tree classifier, random forest regressor, and AdaBoost boosting algorithms, which includes AdaBoost, XGBoost, and lot many boosting algorithms. And Apart from that, coming to the unsupervised learning algorithms, which includes mainly clustering algorithms and dimensionality reduction techniques. So dimensionality reduction techniques mainly includes to remove the independent variables which are less correlated with respect to the target variable. So based upon correlation coefficient factors, we're going to identify how a particular variable is related to the target variable. So accordingly, if it is less correlated, then it makes sense that to drop a particular variable. And because it's not going to affect much with respect to the target variable. So we'll drop those. So we'll try to discuss those techniques in dimensional reduction technique and clustering. Clustering is mainly for grouping the data. So similar kind of data will be grouped together. So these kind of techniques we are going to discuss in unsupervised, which includes k-nearest neighbors, dbScan, and couple of algorithms as well. And coming to reinforcement techniques. So in reinforcement techniques algorithms, so as we know that reinforcement is something where machine machine try to learn by itself by running the same piece of code again and again using trial and error method. So if someone comes to you and says that as a programmer in general, if you are trying to run same code again and again, it won't change. It will give you the same error at the first time, whatever it has been prompted. So we'll not be able to change that particular output. But that's where reinforcement techniques comes into the picture. Based upon the previous trained input, it tried to learn the input and try to auto correct it and try to rectify the previous mistake what is happened so that the same mistake won't happen in the future. So that's where we'll call about reinforcement techniques. And once this is done, then we also need to learn about deep learning. So what is deep learning? Deep learning is a subset of machine learning, so which includes where we have to learn more about ANN, which stands for artificial neural networks, CNN, convolution neural networks, and RNN, recurrent neural networks. So where in RNN, we are going to discuss mainly about time series techniques, where they, based upon the previous time series data, it's going to learn automatically from the past trained data, the previous input. So that's where we discuss in detail about these techniques. And if someone asks when deep nowadays, I mean, I am seeing that from past a couple of years, deep learning has becoming famous. So if someone comes and asks you that is deep learning famous only in the is deep learning came into the existence in the early 20s, early 2000s? If someone asks, what might be your answer? Definitely yes, but no. Deep learning is there in the year 1950s, 1960s itself, but there are a lot many scientists discovered this deep learning techniques in the year 1970s or 1960s, but there were no hardware machines which are capable of handling it. So that's the reason there were a lot many debates happened in a lot many conference pages, and then they drop and then they again started with that. So we'll try to learn more about when we are trying to discuss about AN and how this came into the existence. So previously there were BNN, biological neural networks, so where it got inspired by neuron. So that's where neural networks has becoming famous. And one more point to be added is, in order to learn more about neural networks, we also need to be good at matrices, so which includes where we have to calculate how the matrices works, how the differentiation works, how the integration works. So we have to be good at this kind of various techniques. And once the development is done, in order to deploy it or use as a storage system, we also needs to be good at either cloud platforms. I mean, any of the cloud platforms includes AWS, GCP, or it can be Azure, or it can be IBM Cloud, or it can be OneCloud offered by Rakuten. So it's my company where I worked for almost 1.5 years, tool where I gained a lot of work experience. And coming to the, so this is the tech stack that's required for a data scientist. And if I give you a roadmap or life cycle of a data scientist project is basically data scientist main work stands only with data modeling part. But remember guys, if you are only good at data modeling part, There are very less companies who will recruit you only for data modeling part, because companies want to be you to be good at multiple areas. So it includes knowledge on the data engineering skills, knowledge on the data science skills, knowledge on the data analyst skills, and knowledge on the deployment skills as well. It doesn't mean there might be some SRE team or some other person responsible for your deployment of your code. We need to have a knowledge on all these areas so that you alone will be able to handle the entire project, starting from data collection. You can do data pre-processing, data validation, further you can do data modeling and data testing, data validation, for the data deployment. So for deployment, it can be, we can deploy it in any of the free cloud services, and then you will be able to run the program by itself. So that's where these are the concepts. And now I'll talk about what are the steps that one has to follow to become a data scientist, or what is the major steps or challenges that one has to follow, especially in the part of data modeling part, guys. So I already explained about the steps that one has to be followed in data engineering process, that is data pre-processing techniques, which while extracting the data from multiple sources. So now I'll be talking about the main process present for a data science project. So basically it starts with, once you get a data from a data engineer, remember guys, every data scientist will work closely with a data engineer to understand the relationship give from the given data. So what kind of relationship present? So do we need to have these kind of variables if it is highly not correlated with the target variable? So one has to understand a lot much about the data, and then data scientist will suggest you an appropriate algorithm based upon how the data looks like. So basically we start with data collection. So that means once the data has been prepared by data engineer, we'll be having a look at the data to identify various trends present in the data. Once you identify the various trends, there might be a step process where you have to do some feature engineering techniques. So what is meant by feature engineering? So feature engineering is something about where you will be involved lot much in terms of a data pre-processing, which includes performing exploratory data analysis, handling missing values, handling outliers, handling categorical encoding, handling normalization, standardization. Don't worry, guys. I'll explain you about what is normalization, what is standardization, and why are we using this. And once feature engineering steps are done, the very next step that we are going to talk about is, as I mentioned earlier, that we have to ensure that whatever the variables that we are giving from the data engineer perspective, do we need all the variables with respect to target variable? If they are not highly correlated, so we can drop those variables. That doesn't make much significance. So this process, we'll call it as feature selection techniques. So in this, we are going to understand more about correlation coefficient factor, that is Pearson correlation coefficient, forward elimination, backward elimination, random forest, feature engineering techniques, feature exploration techniques. So these are the various things that we are going to discuss over here. And now we are done. So next comes the data modeling part. So where we'll implement an appropriate algorithm. Either it can be starting with supervised, unsupervised, or reinforcement, or it can be deep learning algorithms, depending upon how the data looks like. You will try to get an accuracy of a model. And then we have to perform some hyperparameter tuning techniques, which will improve the accuracy. So just improve the accuracy by following hyperparameter tuning techniques, then try to increase the accuracy. So there are multiple techniques to improve the accuracy that we are going to discuss. So one thing mainly used by ridge regression, L1 and L2 regressions, and grid search CV, randomized search CV, and we can tweak a few of the encoding variables, and then you will be able to, which are less coefficient variables, we can drop those from the given data set, and then we will be able to increase the accuracy of a model. So these are the various things. So once this is done, the model is ready, and then we are able to improve the accuracy of a model by following from model tuning and hyperparameter techniques. What is the next step, guys? The next step is model deployment. So what's happening in model deployment? So in model deployment, basically, we are going to discuss more on continuous integration and continuous deployment pipelines, where nowadays it is getting automated using Docker, Kubernetes, etc. So there might be a standard procedure for that. Or if you are trying to deploy using any of the cloud services, so we can enable the cloud services and we can deploy that in a cloud. And the final step is we are just need to monitoring the model. So how the metrics is evaluating, and if something goes wrong, we have to retrain the model and improve the accuracy accordingly. So these are the various steps, guys. So from these are the various steps, guys. So if you have any query in any of the discussed tutorial, you can just comment in the comment section. So I'll be happy to help you guys. And one more, I just wanted to update an information, guys. From my next class, I'll be getting an marker. So where I'll be sharing my screen, and then we'll be using a white dashboard. So rather than virtual, so I want it to be much more interactive, guys, so that I'll share my screen and then I'll write over there whatever we are discussing, so that it will be easy for you to have a look at my videos. So since this is my early phase, so I'm going to purchase it soon. So might be tomorrow or day after tomorrow once I get time. So and then hopefully I'll be uploading all the videos related to data science. So this is an important notice. And one more super important notice is so that soon might be the next series I'm going to start is, as I said earlier, my main concentration will be on mathematics related to the data science rather than on programming. So basically, it doesn't mean I will not teach about programming. Programming also will come into the picture, but first I'll concentrate majorly on statistics and the optimization methods, guys. So remember, guys, one can learn statistics anywhere. It can be through online YouTube tutorials, or it can be through online papers, or you can browse on internet. You can through the one book which I suggest for you guys to statistics is Hedford Stats books. It's very nice, guys. And the other thing is optimization methods for data science. So apart from usual machine learning algorithms like L1, L2, ridge, lasso, regression, grid search CV, randomized search CV, so we are going to discuss about the optimization techniques that are present in linear algebra, calculus, probability, polynomial equation, how integration, differentiation are going to affect us, how much importance does it place in neural networks or in optimizing a certain algorithm. So from the next series, I'm going to start videos majorly on optimization techniques and statistics. So if you want to get my following updates, just subscribe to my channel and click the bell icon so that you will receive a notification soon whenever I'll upload my video. And thank you, guys. Thank you. Have a good day. Hopefully meet you soon. Thank you. Bye-bye.